Everyone, let's solve the second question from today's weekly contest, that is closest nodes queries in a binary search tree. So you are given the root of a binary search tree and an array queries of size n consisting of positive integers, and you have to find a 2D array answer of size n where answer I is equal to min I comma max I. And what is min I? Min I is the largest value in the tree, that is smaller than or equal to queries I. If such a value does not exist, we have to add -1, and max I is the smallest value in the tree that is greater than or equal to queries I, and if such a value does not exist, we have to add -1 instead, right? So let's understand it with the example given in the question, right? So what we are given is this binary search tree. What is a binary search tree? A binary search tree is a tree in which is a binary tree basically, in which we have the root is greater than the left child and less than the right child, right? So we are given a BST, right? And we are given this queries array, right? Now what this queries array is, we have to check for each query. We have to calculate min I comma max I, and we have to return it inside of an array, right? So what is min I and max I? So let's see. So min I is basically any number inside of the binary search tree which is less than min I, but it should be the largest value which is less than min I, right? And max I is any value in the binary search tree, like it should be the smallest, but it should be larger than this max I, right? So let's run through this. So for the first query, we have 2, right? So let's see. Let's calculate min I for 2 in this binary search tree. So what is min I? Any, also they can be equal, right? Any number in the binary search tree, it should be the largest, but it should be less than min I, right? So let's check if there are how many numbers are less than equal to less than equal to 2, right? So 2 and 1, right? And we have to pick the largest of them, so which is 2. So we'll take 2 in this case. Now what is max I? Max I is any number that is greater than equal to the query given, but it should be the smallest among all, right? So let's see the numbers which are greater than max I. So all these numbers are greater than equal to max I, but we have to pick the smallest out of them, so which is 2 in this case. So this is the first, this is the answer to the first query. Now let's move on to the second query. The second query is 5, right? So for 5, we have to calculate min I. What is min I? Min I is any value that is less than or equal to 5, but it should be the largest. So let's check the values that are less than 5, less than equal to 5. So all these values, right, 2, 1, 4 are less than equal to 5, and we have to pick the largest out of them. So which is the largest out of them? 4. So we will take 4 in here, and then we have to calculate max I. What is max I? Any value which is greater than equal to max I, but it should be the smaller, right? Smallest value among all of those values that are greater than this, that are greater than the query, right? So all the values here, as you can see, all these values are greater than 5, right? But we have to pick the smallest out of them, so which is 6. Similarly, we'll do for our last query, that is 16. So for 16, if we calculate min I, we have to take all the values that are less than 16. So all these values are less than 16 in this binary search tree, but we have to pick the largest out of them. So the largest value that is smaller than 16 is 15, right? So we'll take 15 in here, right? And for max I, we have to take the value which is greater than 16, greater than equal to 16, but it should be smallest among them. But in this tree, there is no 16, right? Or any value that is greater than 16. So that means we have to put -1 here, right? In such cases where we cannot find any value that is less than equal to or greater than equal to given query, we have to put -1, right? So this is, we have to create an array of this and we have to return that. So how the question is clear to you now. So let's see how we'll solve it, right? So if you're aware, if of tree traversals, we have three types of traversals: in order, pre-order, and post-order, right? So if we traverse a BST in order traversal, we get a sorted array, right? We get a sorted array, right? So that is what we are going to do. Now what we will do of this sorted array, right? So as you can see, we have to just find numbers which are greater than or equal to a particular query, or less than or equal to the particular query. So in that case, when we have a sorted array of this whole tree, we can simply apply binary search to this sorted array, and we can pick the elements by modifying the binary search a little bit. We can pick the elements which satisfies our condition for mini and maxi, right? So I hope you have understood like what we are going to do. So let's see the code. It will make things more clear, right? So here inside this code, what I have done is I have created this vector v. What this vector v is doing is, it is for in order traversal, right? So I have made this function tfs to calculate the in order traversal of this tree, and after I have calculated that in order traversal, I have put that in vector v, right? Now this is the ans vector that we will be using to put the values for mini and maxi for each query. And inside this for loop, right, I have assigned these two variables values from two functions, right? The first function is closest mi. So the closest mi function is calculating the closest minimum value, right? That is the largest minimum value to the query given, right? And the closest mm function is calculating the query is calculating maxi, right? Which is the smallest value that is greater than equal to the query given. And then I'm putting that inside of my vector, right? So let's see what I have done in the closest minimum function. So in the closest minimum function, I've taken a mi variable. Now what this mi variable contains is -1. It is initialized to -1 because what if we don't find any value in the tree that satisfies the condition, right? So in that case, we have to return -1. So I have initialized it to -1. So in case we don't find any value, so we'll simply return mi like this here. Now inside this loop, I have applied binary search. As you can see, I'm calculating low, I'm calculating mid, right? So if my in order traversal, that is my sorted array, if it contains the value, right, that is the value that is the query, right? If it contains that, we have to simply return it, because our mini and maxi, they can be equal to it, right? If they are not equal, then we have to find the smallest or the largest value, right? So now in this statement, we are simply seeing if our mid value is greater than the query, then we have to move to the left part of the array, right? And if it is not greater than the query, then we have to do what? We have to update our mi to whatever the largest value that we have find, and we will move to the right part of the array by doing low is equal to mid plus 1. So as to calculate if we have more larger values present, right, that is still smaller than the target, right? Then in the closest maximum function, we have done the similar thing but modified it a bit. So first, if vmid is equal target, right, so we have to simply return whatever the value we have found, because if the BST contains a particular query, we have to simply return it. In case the mid value is less than the target, right? If our mid value is less than the target, then we have to move to the right part of the array, because we have to find a value which is greater than the target, right? And then inside of else, we are updating our right, the maximum value, and then we are moving to the left part of the array to check if there are any smaller values that are still greater than the target, and then we are returning So that is basically how we have to solve this question, and I hope this is clear to you.